Hello and welcome to this very brief presentation related to completing the square. We will use a 6-step procedure to solve a quadratic equation using the completing the square method. Here's a brief presentation outline. We commence with an overview of the completing the square method. Then there are 3 fully worked examples. Example 1 solves this quadratic equation. Example 2 solves this equation. And example 3 solves this equation. The presentation concludes with some questions for you to attempt to help you practice the completing the square method. And here are the approximate start times related to the various sections contained within the presentation, hopefully to aid your ease of access to the presentation. Please note that within my explanation of the worked examples, I do sometimes conflate my positive and negative with my plus and minus. But I hope my misuse of the terminology doesn't detract from your understanding of how to apply the completing the square method, as that's the essence of this presentation.
The completing the square method can be used for such applications as solving quadratic equations. You're probably already used to using the graphical method or factorization or the formula to solve quadratic equations. Well, we can solve quadratic equations also using the completing the square method. We can also use a completing the square method to simplify Laplace transforms and in some cases make them into standard forms. The generic procedure shown below is going to be used in all the examples in this presentation. This is a 6-step process. So step 1, we're going to be given a quadratic equation having the form ax squared plus bx plus c equals to 0. Step 2, we're going to rewrite the equation so only the x terms are on the left hand side of the equation. So looking at the generic equation, that will mean the ax squared plus the bx are on the left hand side and then the constant term is taken to the right hand side. At step 3, we're going to take half of the coefficient of the x term. So look at the x term, take half the coefficient, ignore its sign, we're not bothered if it's positive or negative, and we're going to square that value. So it'll be half of b and we're going to square the half of b. Step 4, we're going to add this squared value to both sides of the equation to keep the balance of the equation. Step 5, we're going to convert the left hand side of the equation into a squared form. We're going to factorize it, in other words, and we're going to numerically simplify the right hand side of the equation, just adding the values up. Step 6, we're going to bring all the terms back to the left hand side of the equation, so the equation equals to 0. I will also show you how to solve the equations to find the roots in some examples. Example 1 here, quadratic equation given is x squared minus 8x minus 25 equals to 0, and we're going to complete the square on this question. So I'm going to follow my 6-step process through again. So here we've got x squared minus 8x minus 25 equals to 0. So step 2 says we need to move the constant, the c term if you like, to the right hand side. So I get 25 on the right hand side. I'm adding, if you like, 25 to both sides of the equation. That leaves me with all the x terms on the left hand side. So x squared minus 8x. In step 3, we're looking for the coefficient of the x term. We're ignoring the sign here. It is actually a minus 8, but we're just considering the magnitude, the 8. We're going to half that value, so half of 8 gives me 4, and we're going to square the 4. So the numerical value there is 16 for half the coefficient of the x term squared. We're then going to, in step 4, add that 16 to both sides of the equation. Adding it to the left hand side will help me factorize the equation. It will simplify the factorization. On the right hand side, it keeps the balance of the equation. And step 5 here, we're going to factorize the left hand side. So basically it will be x minus half the value of b, which half the value of 8 is 4, so minus 4 in this case, all squared. That will give me the left hand side of the equation, and on the right hand side I'll just simply add the 25 with the 16. Finally, I just bring the 41 from the right hand side to the left hand side by taking 41 from both sides of the equation. So I've managed to take the x squared minus 8x minus 25 original expression, and using completing the square method, I've put it into the x minus 4 all squared minus 41 expression. Okay, we're going to solve example 1 to find the roots of the equation. I've repeated the equation here just for convenience here. So we're solving x minus 4 or squared minus 41 equals to 0. The solution steps here will be add 41 to both sides to give us the next line. Get rid of the squared, we will square root both sides. So I get x minus 4 is equal to the square root of 41 on the right hand side. Don't forget, when you square root a number, you get two solutions, a plus and a minus. So I've got plus or minus 6.4031 here. I'm using 4 decimal places here. Then finally add the 4 to both sides of the equation to get the final equation for x. So x is equal to plus or minus 6.4031 plus 4. So the two solutions are x equals 10.4031 and x is equal to minus 2.4031. So our roots of the equation, our solutions or our roots of the equation, we get x equals to 10.403 and x equals to minus 2.403 to 3 decimal places.
Let's consider example 2. We're given the quadratic equation 2x squared plus 6x minus 4 is equal to 0. To solve this using completing the square. So undertaking our procedure, here's the equation given in the example. Firstly, what I've done is to factorize on the highest common factor for the equation, which is 2 in this case, so I have 2 outside the bracket. So in the bracket I have x squared plus 3x minus 2, and that's where I'm starting my procedure from. I'm just initially going to consider the bracketed term here equated to 0, but I mustn't forget the 2. I will include that again at the end of the completing the square process. So step 2, rearrange the equation, so just the x terms on the left hand side, so I've added 2 to both sides of the equation. I then note the coefficient of the x term, which is 3 in this case, and now I have to write half the coefficient of the x term squared, so that's 1.5 squared. That actually equals to 2.25. My next step, I add the 2.25 to both sides of the equation. The next step, I now factorize the left-hand side, so that will be x plus, in this case, half of the b term, half of the 3, so 1.5, and that's all squared. And that equals to, on the right-hand side, 4.25. Next step, I subtract 4.25 from both sides of the equation, so the equation now equals to 0 again. So I've completed my square. I must remember to bring back the 2 from the original factorized equation to form the final solution, shown here. So, commencing with 2x squared plus 6x minus 4, using completing the square, we've ended up with 2 outside our square brackets, x plus 1.5 all squared, minus 4.25 in our square bracket. If we now solve example 2 to find the roots of the quadratic equation, just restating the completing the square form from the previous slide. First thing here is I've divided throughout by 2 to produce this equation. I've added 4.25 to both sides of the equation. I've then square rooted both sides of the equation. You always end up with a positive and negative answer, which I've stated here to 4 decimal places. Next line, I've added 21.5 to both sides of the equation. So now we have the equation x is equal to positive and negative 2.0616 plus 21.5. First solution is 2.0616 add 21.5. Produces our first root. And the second solution we have negative 2.0616 add 21.5. Produces a second root. So the roots of the equation occur at x is equal to 23.562 and x is equal to 19.438 to 3 decimal places.
Final example I will look at example 3, very similar to the previous example. We're given an equation here, minus 2x squared plus 8x plus 3 equals to 0. I'm going to use the completing the square method again for this equation. Again, I'm going to factorize it on, in this case, again, 2 is the highest common factor I'm going to use here to get my x squared term here. I must have an x squared term here. So I'm going to take minus 2 outside this time. And just be careful with the directed numbers here. When you take the minus 2 outside, you'll get positive x squared inside. You'll get negative 4x, because when you multiply that by the minus 2, you get a positive 8. And you'll get a negative 1.5 for the constant. Again, when you multiply that by minus 2, you get positive 3. Just be careful of directed signs there if you write it in that format there. So again, I'm just going to apply my completing the square technique to this equation. So step 1 gives me my equation in the form of ax squared plus bx plus c equals to 0. Okay, step 2 says to move the constant to the right hand side to leave all the x terms on the left hand side, so that's what I'm doing there. So x squared minus 4x on the left hand side is equal to 1.5 on the right hand side. Noting my coefficient of the x term in this case, the magnitude of it is 4, so half of that is 2, and 2 squared in this case will give me a value of 4 for step 3. Step 4, I add the positive 4 to both sides of the equation, keeping the balance. And step 5, I then factorize the left hand side. So x squared minus 4x plus 4, when you factorize it, that'll be x minus 2. The 2 is half of the 4 there, all squared. And that's equal to the 1.5 plus the 4, the 5.5. And in step 6, I just bring all the terms to the left hand side. So I get x squared minus 2 all squared at minus 5.5 equals to 0. Don't forget though the original minus 2 from the original equation, so I factor now everything by minus 2 to get my final solution. So again, minus 2x squared plus 8x plus 3 using completing the square can be written as minus 2 open bracket x minus 2 all squared at minus 5.5 close bracket equals to 0. Over the page I've shown how to solve this equation. It's very similar as before, so I won't labour that with you. I'll leave it there for your information. I'm going to leave you with some tutorial questions to solve here using completing the square method. The first 4 questions I should say, question 1, 2, 3 and 4, all ask you to complete the square and to solve for the roots of the equation. Thereafter it just asks you to complete the square. Thank you for viewing this short video.